Welcome to lesson 1-5 video 2, and we are going to be talking about continuous domain and range. Okay, so in class today I asked y'all to look at this and just think to yourselves, what does discrete mean? What does continuous mean? And the way I like to think about it is that discrete, anytime you have a discrete variable, it's one of those situations where it doesn't make sense to take on values in between. So the last, if you remember back to the last video, 1-5 video 1, we talked about the AP scores. You know, those students could score either a 1, 2, 3, 4, or 5. So that's discrete data because you can't score a 1.5 or a 1.1 or a 1.2, and we answer that question, does it make sense to connect the dots? And no, it doesn't make sense to connect the dots because there's no values in between that you can have data for. And that's an example of discrete. But when it does make sense to connect the dots, that's what we call continuous data. One example we used in classes today that I asked you all to think about when you've gone to take a glass and fill up that glass with water. And if you go to the faucet and you put your cup underneath the faucet and then you turn on the faucet and you watch that water level, it's going to rise slowly, right, and continuously. It's not going to start here and then jump up to the next one and then jump up to the next one and then jump up. That would be crazy, right? You're going to watch it continuously rise. And then similarly, if you go to your freezer and you get out some ice to put in your drink, that can kind of be related to or into your water, that can kind of be related to a discrete, because like a discrete variable, because you can count each of those ice cubes, right? You can get 3 ice cubes, you can get 4 ice cubes, you can get 5. So kind of think about it like that. Here's another example where we have Lite-Brite and Etch-a-Sketch. Lite-Brite, you have those individual values there, those little pegs that you plug in. And then Etch-a-Sketch, it's continuous because that little stylus is continuously moving. It doesn't ever pick up off the screen, and you have to move the knobs and think about your next move because it's never going to pick up off the screen, so you have to be mindful of that. Okay, so let's talk about set notation and interval notation. So I'm going to go ahead and unhighlight each of these. So anytime we use set notation, by the way, set notation is what we've been using so far, and it's what we used in that Desmos activity yesterday, or what you probably used, unless you're absent. But anytime you're dealing with set notation, you're going to be dealing with less than signs or greater than signs. Anytime they don't have the line underneath it, that means that this is an open circle, okay? And these right here with the line underneath it, that means they are the closed circle. And anytime it's a closed circle, that means we do include the value that's listed there, okay? It's because our domain and range can be equal to that value. But anytime the boundary is not included, we either use less than or greater than, because the domain and range cannot equal that value. So every value up to it, but except that value itself, it can be. So when either negative infinity or positive infinity is used, you're going to use less than or greater than with no line underneath it. And the reason is because you can never actually reach infinity. Okay, so now let's go and talk about interval notation. So we are going to use brackets when the boundary is included. So these are what brackets look like. And this is when you have a filled in circle on your graph, or like continuous on the graph with no breaks. And we use parentheses when it is not included. So parentheses would be like an open circle on the graph. And we use parentheses when a boundary is infinity or negative infinity, and again, because you can never actually reach infinity. So these are 2 different ways to represent the same thing. We're going to use both of these to represent domain and range, and we'll see that in the examples below. So let's scroll down here. And the first thing I'm going to have you do for this example is go ahead and put an arrow on the end of this, because we want this to be like this graph is going forever and ever this way, and then we'll calculate or figure out the domain and range with it like that. Okay, so if I were to look at this function and think back to that Desmos activity, there's no starting point on the left here, okay, because this graph goes on forever to the left. So here's negative infinity on the x-axis, here's positive infinity. So our beginning point, and really you can't call it the beginning point, but our start is going to be negative infinity, and it's going to go all the way up until you reach this point on the graph right here. So we're on the x-axis where x is equal to 4. And we know that x is between those two values. So I know that x is less than 4, and I know that x is greater than negative infinity. Now, we went ahead and used just less than symbols here because this is an open circle and this is infinity right here. But generally, you don't have to write this whole thing. You're welcome to, but generally you will see this written with just x is less than 4, because it's implied that if x is less than 4, then all of this graph here is included all the way forever and ever this way. Okay, and that is for set notation. Now, the reason why I usually will like to start with that is because, like with this right here, is because it's easy to convert this to interval notation. So let's come over here. Because I'm using just less than symbols, I'm only going to be using parentheses, and you're going to use the same values that are here and here. So we'll do negative infinity to 4. Okay, so that is the same thing. And then infinity, you can just do by drawing a sideways 8. That's the best way to think about that. So that's domain. All right, now let's talk about range. So range is going to be up and down, and I am going to switch this over to orange. Now, the absolute topmost point of this graph looks like it's about right here. Okay, and I would say that's probably about 3.5. And then it also looks like that the graph goes down. It doesn't actually stop here, right? Because this graph continues to point down, and this arrow means it keeps going. So this graph actually goes forever to negative infinity. So let's represent that here in the range under set notation. So we're going to say y is between negative infinity and 3.5. I'm going to use less than or equal to here, and just less than with the negative infinity. And again, remember, you can think about this. You don't have to write this part, the negative infinity less than. If you have it like this, you could just say y is less than or equal to 3.5. But I do like to write it like that to begin with because it helps us write interval notation. All right, now, so why is this less than or equal to? Well, up here, there's no break in the graph. There's no hole in the graph. So we do need to include the point 3.5. So that's why. And then we always use just a less than symbol with infinity or negative infinity. So let's convert that. So this less than symbol is going to be a parenthesis, and this 3.5 is going to be a bracket. So now I'm going to put in negative infinity and 3.5. All right, so let's go on to example 6. All right, so give the domain and range of this continuous relation and set an interval notation. First off, and this is what we'll get into a little bit later, but think about what's going on the x-axis. You've got an arrow that's going infinitely in this direction and in this direction. So that means that x is going to be between positive infinity and negative infinity. And what we like to call that when we have a situation like that, I'll go ahead and write it down. So x is less than positive infinity and greater than negative infinity. We actually call that all real numbers. And I like to write a capital R with another line going through it like that. And you can write it like this. You can also write it like this. Okay? Let's convert that to interval notation. So, and again, I use less than because we're talking about infinity. We do not include infinity. So that means here we're going to have parentheses, and we'll do negative infinity to positive infinity. Okay, let's move on to range, and let me change colors here. So now we're talking about up and down. So I have positive infinity up here, and I have negative infinity down here, and all my y values in between. And this graph is continually decreasing, or it continues to go down. It also continues to go up for infinity. So we can go ahead and start to say that the range is going to be all real numbers. You can also represent it like this, but don't use an x. We've got to use a y. So y is less than infinity, but greater than negative infinity. And then interval notation, you can say it the same way that we did this right here for domain. Okay, so go ahead and try the utry. One thing I want to note before you do this, there are many ways that we can say the same thing. Okay, and we just got introduced to all real numbers. Generally, we like to write a capital R. Okay, you can write it like this, capital R, and then draw a line through it. Or if you just put an R, that's fine. I'm going to know what you mean. But these are all the same ways to represent all real numbers. You're welcome to write it out on your page. You're also welcome to do it in this notation and this notation. All right, I'll see you in the next video.